Mr. C here. We are going to start out our new semester with Unit 6, Day 1. We are going to be looking at the multiplication property of exponents today. So make sure you have your notes and make sure you're taking good notes and writing down questions as they come up so we can address those in class and use our class time wisely. So we are going to be starting vocab, but we are going to take this portion in class. Alright, so bring your notes to class and we'll cover the vocabulary portion of it, and as well as this. What I want to get into is really the meat of the lesson. And so, first things first, we need to recall what an exponent is. So, an exponent, also called a power, it represents multiple, repeated multiplication. So, for example, in this 3 to the 4th, 3, that's called our base. That's called our base. And 4, that's our exponent. And what this is saying is I'm going to take my base. I'm going to take 3, and I'm going to multiply it by itself 4 times. So if I were to expand that out, what that's going to look like is 3 times 3 times 3 times 3. And then that simplifies to give me 81. But it's just saying I'm taking 3 and I'm going to multiply it by itself 4 times. It's an easier way than to constantly be writing this portion right here. 3 times 3 times 3 times 3. That's a little bit too much, so we just say 3 to the 4th power. Now, what if, and this is going to be new, what if we're trying to find the product of powers? So if you'll notice, in both of these cases, I have the same base. I have the same base of 2. But I have 2 different exponents. I've got a 2 squared, and I've got a 2 to the 4th power. So, what is going to be an easy way to figure out what that new exponent is going to be? Well, let's first look at what happens if we were to expand this. So if I expanded 2 squared, that's saying I'm taking 2 times 2. Now, if I'm going to expand 2 to the 4th, so first off, I took the 2 blues, and I said 2 times 2. Now I'm going to take 2 times 2 times 2 times 2. I'm going to expand that 2 to the 4th power. Now, this is all being multiplied together. So if I look at this, 2 times 2 times 2 times 2 times 2 times 2, how many times am I multiplying 2 by itself? Well, I'm multiplying 2 by itself 6 times. Now, how can I get 6, this new exponent, how can I get 6 from 2 and 4? What is the pattern? What's the pattern here? Well, the pattern is that I'm going to be adding the exponents. When you have the same base, so for example, the same base here is 2, and you have different exponents, you can add those exponents to get to the new exponent. And that is what this little chart, this little table tells you in your notes. A little bit of math numbers, or math lingo, but it gives you a couple good examples that I want to make sure you look at. So if you have the same base, all you have to do is add the exponents to get to the new one. So let's look at a couple of examples. Simplify each expression. Just at first glance, you can see these problems can be a little bit complicated. You've got a lot of numbers, you've got a lot of different variables. So how can I simplify this? Well, what I want to do is I want to group together the different, similar variables or similar numbers. So for example, in A, what I want to group together, I want to group together 6 times 2. I want to group the numbers together. The next thing I want to group together are the n's. I've got n cubed times n to the 7th. And then I've also got an m squared here. There are no other m's, so m squared is just going to be by itself. Now, I can do this in math. When I'm multiplying all these different values together, what I can do is I can rearrange those. And that's actually going to make my life a little bit easier. Because once I group them together, I can just multiply. 6 times 2, that's 12. N cubed times n to the 7th power. Well, the base stays the same, and all I need to do is add those exponents together. 3 plus 7 is 10. And then last but not least, I've got m squared. Can't really change that at all because there are no other m's. There you go. That's my simplified expression. Similarly, in b, what I want to do is I want to group together what I can. I've got negative 4 times negative 6. I have r times r to the 5th, x squared times x squared, and then last but not least, I've got t cubed times t. And there, I've accounted for everything that was in my original problem. I'm just rearranging it so similar parts are together. And then I can just multiply. Negative 4 times negative 6 is positive 24. Remember, a negative times a negative is always going to be a positive. R times r to the 5th. Well, I don't have an exponent on this r. What's going on right here? I don't have an exponent. Well, if there is no number there, remember, it's just going to be r to the first power. Your exponent's going to be a 1. So r to the first times r to the 5th, that's going to give me r to the 6th power. X squared times x squared is going to be x to the 4th. And last but not least, t cubed times t is going to give me t to the 4th power. And that is my simplified expression. If you have any questions on these two examples, make sure you write them down so that you can let me know. Moving on to the final concept that we're going to be talking about, plays very similarly into what we just discussed. But what if we have an exponent raised to a power, and then that whole thing is raised to another power? So for example, I've got 3 to the 2nd power, but that is being raised to the 4th power. So how can I find my new exponent? Well, once again, what we want to look at is we want to look at the expanded version. What is this saying? Well, this is saying my base, which is 3 to the 2nd power, is being multiplied by itself 4 times. So I've got 3 squared times 3 squared times 3 squared times 3 squared. Well, using what we just learned, I can keep the base the same, and then I can add all these exponents. 2 plus 2 plus 2 plus 2, that's going to give me 8. So 3 squared raised to the 4th power simplifies to give me 3 to the 8th power. So what's the pattern? How do I get to 8 from my original exponents of 2 and 4? Well, I've got 2 times 4 equals 8. So when I have a power raised to a power, what I want to do is I want to multiply the exponents. And that is what that chart is going to say in your notes. Gives you a couple more examples and then also rewords what we just discovered. So make sure you look at those examples, you understand what's going on. When you've got a power to a power, you're going to multiply those exponents together. Let's finish out with a couple different examples. And again, these can look complicated, but you just got to take it step by step. So in A, what I'm going to start with is my base, 2 to the 3rd power. Well, 2 to the 3rd power, that right there is being raised to another 3rd power. So the base is going to stay the same. The base is going to say 2. But then what do I do with these exponents, those 2 3's? I'm going to multiply them together because it's 2 to the 3rd power raised to the 3rd power. So it's a power to a power. So inside the brackets, this simplifies to give me 2 to the 9th. And then I've also got this looming 2nd power on the outside. Again, I've got a power raised to a power. So what am I going to do with that 9 and that 2? I'm going to multiply them together, leaving me with 2 to the 18th power. 2 to the 18th power. We can use our calculators now in order to simplify that. 2 to the 18th power is 262,144. So that's definitely something you're going to want to use your calculator for. Now, in part B, we get a little bit more complicated. I've got this expression right here, 1/2 a squared b squared raised to the 3rd power. What I need to do is I need to apply that 3rd power to everything going on inside those parentheses. So I'm going to have 1/2 raised to the 3rd power. I'm going to have a squared raised to the 3rd power. and I'm going to have b squared raised to the third power. Over in this group, inside these brackets, I've got a similar situation going on. I've got negative 4b in parentheses being raised to the second power. So I need to apply that 2 to both parts. So I'm going to keep my brackets, but I've got negative 4 raised to the second power, and I've got b raised to the second power. In this red grouping, I'm not quite done though, because I've still got this 2, this raised to the second power, outside those brackets. So let's go back to the beginning right here where I've got my blue steps, and let's simplify that. 1/2 raised to the third power. That's saying I'm going to take 1/2 times 1/2 times 1/2, and that's going to leave me with 1/8. And then I've got a squared raised to the third power. Power to a power, I'm going to multiply those two numbers together. Similarly in b, I'm going to multiply those exponents together. And that simplifies my blue step. Now let's take it back and simplify what's going on inside the brackets. I've got negative 4 squared. Now make sure you notice you're taking negative 4 times negative 4. That exponent of 2 is multiplying, the exponent of 2 is being applied to the base of negative 4. So I'm taking negative 4 times negative 4. Negative times negative gives me a positive. So negative 4 squared is 16. And then b raised to the second power is just going to give me b squared. And then I've got this exponent of 2 on the outside of those brackets. So now I have to apply that to everything going on inside the bracket. Let's drop down the blue. And now inside the bracket, what I've got going on, let me scroll down. I've got 16 squared and b squared raised to the second power. So, I know it's a long problem. Stay with me. So I got 1/8 a to the 6th b to the 6th times, and then 16 squared, that is going to be 256. B squared to the second power, power to a power, I'm going to multiply those together. That's going to be b to the 4th. Now, that was all the hard work. Now what we're looking at is a problem similar to what we did a couple minutes ago. What I need to do is I'm going to group the numbers, the a's, and the b's together. So if I look at the numbers, I've got 1/8 times 256. If I look at the a's, I've got a to the 6th all by its lonesome. And then if I look at the b's, I've got b to the 6th, b to the 4th. So going back to the numbers, 1/8 times 256. I'm going to use my calculator, and I get that to be 32. And then I've got a to the 6th. This is just coming along for the ride. And then I got b to the 6th times b to the 4th. The base stays the same. And my exponents, I'm going to add those two things together. I'm not going to multiply them because it's not power to a power. It's just b to the 6th times b to the 4th. So look at what we started with. Let's change that screen size. Look at what we started with versus what we ended. It's a much simpler answer. We just got to make sure we're applying those exponent properties correctly. So what I want you to do now is I want you to look at your notes. You've got a couple you try nows. So what I want you to do is use your time, use the video, use what we just talked about, use those examples and practice those problems. Bring any questions you got to class, and then we will go from there. I will see you all soon.